I just had to let you know you're.
Hey everyone! If differentiation feels confusing, don't worry, you're not alone. In this video, I'll show you simple steps to master differentiation rules. Using easy examples you can understand fast. Let's get started!
Mastering differentiation rules. Let's get started by the power rule. The power rule is used when a variable is raised to a power, like x squared or x cubed. It helps us find the derivative easily. The formula says, if we have x raised to a number, we bring that number in front, then subtract 1 from it. So basically, just bring the exponent down and reduce it by 1. Let's look at the example. We have f of x equals x squared. First, we bring down the 2 down, so it becomes 2x. Then, we subtract 1 from the exponent, so 2 minus 1 becomes 1. That gives us 2x. So, the final answer is 2x. And that's how simple the power rule is. Just bring down the exponent and subtract 1. Now, let's move on to the next. Next, we have the constant rule. The constant rule states that if a function is just a constant number, its derivative is always 0. This is because constants do not change. They stay the same no matter what value x has. So, their rate of change is 0. Let's look at the example. If f of x is equal to 5, the derivative is 0. Similarly, if y equals 10, the derivative with respect to x is also 0. So, no matter what constant you have, the answer will always be 0. That's why this rule is one of the easiest in differentiation. Next, we have the sum and difference rule. This rule is used when 2 or more terms are added or subtracted. It states that we can differentiate each term separately. In other words, we don't need to combine them. We just solve each part one by one. Let's look at the example. We have x squared plus x. First, we differentiate x squared, which becomes 2x. Then, we differentiate x, which becomes 1. Now, we just combine the results. So, the final answer is 2x plus 1. As you can see, it's very simple. Just take it one term at a time. Let's see the constant multiple rule. This rule is used when a constant is multiplied by a function. It states that we keep the constant and only differentiate the function. In other words, the constant stays the same and we just apply the rule to the variable part. Let's look at the example. We are given x times x squared. First, we simplify it. X times x squared becomes x cubed. Now, we differentiate x cubed using the power rule. Bring down the 3, then subtract 1. So, the answer is 3x squared. So, the final answer is 3x squared. This shows that we can simplify first, then apply the rule.
Next, we have the product rule. This rule is used when 2 functions are multiplied. To apply it, we follow this pattern. Differentiate the first function and keep the second. Then, keep the first function and differentiate the second. And then, add the results. Let's look at the example. We are given f of x equals x times x squared. First, we differentiate x, which is 1, and keep x squared. So we get x squared. Next, we keep x and differentiate x squared, which is 2x. So we get 2x squared. Now, we add them together. X squared plus 2x squared equals 3x squared. So the final answer is 3x squared. At first, it may look complicated, but if you follow the pattern step by step, it becomes easy.
We have the quotient rule. This rule is used when one function is divided by another. To apply it, we follow this pattern. Differentiate the numerator and keep the denominator. Minus keep the numerator and differentiate the denominator. Then divide everything by the square of the denominator. Let's look at the example. We have f of x equals x divided by x squared. First, we differentiate x, which is 1, and keep x squared. So we got x squared. Next, we keep x and differentiate x squared, which is 2x squared. So we get x2x squared. Now we subtract x squared minus 2x squared. Then we divide everything by x squared, which is x to 4. So the final answer is x squared minus 2x squared over x to the 4th. This may look complicated at first, but if you follow the step-by-step carefully, it becomes easier.
Next, we have the derivatives of trigonometric functions. These are special rules used for functions like sine, cosine, and tangent. For example, the derivative of sine x is cosine x, the derivative of cosine x is negative sine x, and the derivative of tangent x is secant squared x. Let's look at a simple example. If we have sine x, its derivative is cosine x. These rules are important, so it's best to memorize them.
Lastly, we have the derivatives of exponential functions. These rules are used for functions with exponents, especially those with base e. One important rule is that the derivative of e raised to x is still e raised to x. For other exponential functions like a raised to x, we multiply by the natural logarithm of a. For example, if we have e to the power of x, its derivative is also to the power of x. This makes exponential functions unique and easy to differentiate.
And that's it! Those are the basic steps to master differentiation rules. If this helped you, don't forget to like and subscribe and follow if you want more easy calculus videos. See you next time!
I just had to let you know you're